So we're going to continue with our linear equations, and now we're going to get these linear equations onto the graph paper. And so we're going to learn about looking at them two different ways. We're going to talk about the table method, which we've already laid the groundwork for starting with, and we're also going to talk about the intercept method. And so the intercept method is sometimes useful. It's also a little bit quicker than the table method. After we go through those two methods, we're going to talk about the oddballs. We're going to talk about the horizontal and the vertical lines because they are the oddballs and they bear a little bit of focus. So starting with this one, in the table method is sneakily what I was already doing with you in 6.1. So the table method gives us a way of coming up with solutions to a linear equation. So we're going to take the equation and we're going to solve it for y. Then we're going to make a table. So we got an x, y table. And after we've solved it for y, we know if there's anything that we should be careful about when we choose the values of x. So we choose these ones, and then we solve for the values of y. And this is where you get the x, y in as an ordered pair, and we're going to then graph those onto the graph paper. There is graph paper that came to you in your package. There's probably a limited amount of it. If you do need more, you're welcome to get a hold of me and I can make sure that you get some more. There is also a way of doing it on standard graph paper, or my favorite, honestly, I make real sketchy type graphs. And so in these ones, after you've got your ordered pairs, you can graph your solutions and then draw a straight line through them, putting arrows on the ends. And that indicates that those lines go on forever and there are an infinite number of solutions to that linear equation. So in this one, we're going to start with an example. And I know there's no graph paper down here at the bottom. This is potentially one way that you could do your graphing. So the example that I want to start with is y equals x plus 2. So that's a linear equation. The first thing we're supposed to do is solve for y. Well, it already came to us in that format. And now we can make a table. I don't have a fractional coefficient on my x term, so that allows me to choose any values of x that I want. I mean, anytime you can choose any values of x, but when we have a fraction on that x term, it's a whole lot easier if we stay out of fraction land. So in this one, I'm going to choose 0, 1, and 2. And again, you can choose any values that you want. In these, we're going to be trying to fit them on a graph. And so keeping them small keeps your graph a bit smaller. But what we're going to be doing now is solving for y when x equals 0. So y would equal 0 plus 2, or y would equal 2. And so that would be the first point on my graph. And so I could see it as an ordered pair. That's a weird comma in the middle there. And I could get onto the other ordered pairs that I'm going to have here. So that'd be a 1 plus 2, or y would equal 3. So I'm crunching the numbers to come up with these ordered pairs that I'm going to be able to graph. The last one, I had chosen that x could equal 2. So 2 plus 2, that 2 went in for the x, and so y would equal 4. So this completes 3 solutions for my linear equation. Now technically you would only need 2 to make a straight line, but 3 is kind of there as backup in this first strategy. So I'm going to make a sketchy graph. That is my y-axis. This is my x-axis. I have a much easier time making horizontal lines on my tablet here. So it'd be 1, 2, 3, 4, and 5, and be a positive 1, 2, 3, 4, and 5. You can make them lovely like this. So that'd be a negative 1, negative 2, negative 3, and over here, negative 1, negative 2. You got it. Oops. And on. So now that I've got my graph, I can put my points on this graph. So 0 and 2 would be my first point on the graph now. 1 and 3 would be my second point on the graph. And I could take a straight edge and draw that as a straight line. I do have a third one here as backup. So 2 and 4 would make my next straight line. I don't have a way of using a ruler. I'm sure there is a way of using a ruler with these devices that I'm using, but I'm going to just do a real messy one here of putting my, oh gosh, so that's not a straight line. Use a ruler. Hopefully you're not doing this with a tablet, or you have a way of drawing a straight line with your tablet. Yeah, rulers are good because that's supposed to be a straight line. So if you don't have graph paper, you could always do a sketchy graph like this, and probably yours is going to look neater than mine. I know mine in my book look a little bit neater than this, even when I don't have the graph paper. So that's an example of the table method. The first step of the table method is solving for y. So these are some examples that we can work with to practice that solving for y. And when we did this before, I said we were laying the foundation. I was doing it in a specific way because I knew where we were going. We're going to continue doing that. So I'm going to move the x term away from the y by subtracting 6x on both sides. So that would be wiped out, and I'd have the y equals, I'm going to put them in descending order. So the x term out the front with negative 6 plus 6x plus 6. And that feels a little counterintuitive, but it is going to serve us well as we continue through here. We have seen writing things in descending order is important when we're factoring. So this is now solved for y. So y would equal negative 6x plus 6 is an equivalent equation to that equation that we were given in standard form. So another one in standard form, so this is a linear equation, it fits the model, 2 variables, no exponents. We want to rearrange it to solve for y. So I'm going to start by subtracting x from both sides. That would wipe out, I'd have 2y equaling, oh sorry, I'll do it the way I said I was going to, negative x plus 4. I haven't solved for y yet. I need to divide both sides by 2. So that would get rid of it over here. I would have y equals negative x over 2 plus 4 over 2, knowing that each thing needs to be divided by this 2. This is a step that I tend to skip in coming examples, but I think it's worth showing the first few times. So the key here is writing it as a coefficient and an x term. So my final answer would be y equals a negative 1/2 x plus 2. So a couple things going on there. I took the 4 over 2 and simplified that as 2. And I took this negative x over 2 and broke it apart so I could see it as a coefficient and the x variable. And so there is a 1 in front of that x. It's still a negative coefficient, but I've broken it up so that I can see it, like I said, as a coefficient and the x variable. So this is how I would give my linear equation solved for x. There's 2 more to do down here that are similar to those ones, so I'll talk them through. In b, we want to get y all by itself, so I'd start by subtracting 2x from both sides. That would give me a negative y equaling negative 2x plus 6, again writing it in descending order. And I've not solved it for y, I solved it for negative y, so I'd need to divide everything by negative 1 on both sides. So what that's going to do is switch the sign. So I'd have y equals 2x minus 6. You can show the work, like that step where the 1 is dividing into each of those, or you can do what I did, pushing a little bit maybe, giving the final answer kind of in that step. One more to do with this. So we want to solve for y. I'm going to start by subtracting 4x from both sides. So that would leave me my next equivalent equation as 3y equaling negative 4x plus 12. Again, that idea of descending order. And we haven't solved for y yet. We've got 3y. So divide by 3 and divide by 3. That's going to give me y equaling negative 4/3 x plus 4. I skipped that step. If you want to see it, I'm happy to show it. but it is probably, you know, getting easier to kind of go to this this step here, because what's going on is the 3 is dividing into this and the 3 is dividing into that. And I took that step of simplifying it all in one step. So now that we've got that skill down, let's take a look at this one. So here's one that we can do, and it's got lovely graph paper done for me, so my picture will look a lot better. I'm still not going to have a straight line. So this one, I've got a linear equation. I should solve it for y, but oh, it already is. So that now allows me to choose the values of x and then solve for y. So you can pick any values of x that you want. I always keep them small as possible, and I keep them positive because I make mistakes with negative signs. So you can choose negative signs if you want. Sometimes things do kind of spill off the page, but I typically choose 0, 1, and 2. So in these ones, what I'm going to do, I'm going to solve for y when x equals 0. So y would equal 3 times 0 plus 2, or y would equal 2. So I could fill in my chart there. I could even go so far as to take that ordered pair and graph it. So there's my first point that should be part of my line on the graph. The next one that I'm going to do is that I'm going to take the x as a 1 and sub that in. So y would equal 3 times 1 plus 2. And I'd have that y would equal 3 plus 2, or y would equal a 5. And so having the table gives me a place to record my answers, because this is an ordered pair. It's at 1 and 5 on the graph. Moving on, I can already see that I'm into a bit of trouble. 2 points on the graph should be enough for you to draw a straight line, but the third point in these is always just kind of back up. So evaluating this expression, or this equation, y equals 3 times 2, because that's the x value that I've chosen here, plus 2 would be y equaling 6 plus 2, and y equaling 8. So putting this on the graph, I'd go to the 2, and oh, off the page. So I'm just going to put it there, just sort of a little sketchy, because it's really just there to back me up. If one of your points is way out of line, that is your indicator that maybe you've made a simple little mistake in these, and so take another look at them. So now that I have these points, this is going to be terrible. I'm so sorry that I don't have a straight edge. Pretend this is a straight line. Oh, that could have been worse. So there's my straight line on the graph. I did put the arrows on the end because that line goes on forever. Really need to work on my straight lines in this app on the tablet. Okay, let's do some more. B at the top of page 9 has an equation for us, a linear equation. It's already solved for y, which is great because then I don't have to do all that work. I get to then choose the values of x. Now, when I see that I have a coefficient in front of my x, that's when I have to remember that I can make my life easy. 0 is always going to be an easy choice. But because I have a 2 down below, I'm going to choose multiples of my denominator so that I stay in whole number land. I like fractions, but not that much. So I'm going to pick 2 and I'm going to pick 4. You could pick -2 and -4, or you could pick -2 and +2. It really doesn't matter. I choose the positive numbers because I tend to make mistakes with those negatives. So I'd write out my equation, subbing in the value of 0 where I see an x, and all of that wipes out. See why I like subbing in zeros? -3 for my y. And so I could just put this on the graph right away, kind of processing them one at a time. That's 1 point that's on my line. The next one here, I've got that y equals 2, so y would equal -1/2, and 2 is my value of x, and -3. Take a moment with the fractions. You have -2 over 2, or -1 minus 3, and y would equal a -4 then. And so I can fill that into the chart, so it's in a nice neat spot here for me to graph it. So I'd have 2 and -4 as the next point on my graph. Like I said, 2 points should be enough, but I'm going to do a third one as kind of backup here. So I'd have -1/2 and 4 as my x value that I've chosen. Doing the fraction math, I'd have negative 4 over 2 or a negative 2 and that minus 3, and I get that y equals a negative 5. And so putting that on the graph at 4 and negative 5, I should end up with these 3 points in a nice straight line. And so here comes worst part of my teaching all semester. Oh, look at that, I almost hit all the points. Almost. And it's almost straight. So there's my sketchy straight line. If you can, use a ruler. And again, I can't with this thing. I'm sure there's a way to do it, but I can't figure it out. So I'm doing ugly lines for you. Another one we can do. We've been given a linear equation. This time it is not solved for y. So we need to solve this one for y because it gives us the heads up when we can choose the numbers of x that make our lives easy. So I'd subtract 3x from both sides, and I'd get my equation solved for y as y equaling negative 3x plus 6. There's no fraction on that x variable, and so I'm free to choose whatever numbers I want. I'm going to be boring. Pick 0, 1, and 2. Maybe you want to go out on a limb and pick a negative 1. It should still end up on the same line on your graph. So I like to show my work. I'd have y equaling negative 3 times 0 plus 6, and all of that goes away. So y equals 6. I can fill that in the chart. I could even go so far as to put that on my graph, because then that point is completely processed. The next one that I chose was that x equals 1. So let's evaluate this for y. When x equals 1, we got negative 3 times 1 plus 6. I get negative 3 plus 6, or y equaling a 3. Last one here, again, kind of as backup, but I like having a little bit of that because heaven knows I make mistakes. Negative 3 times 2 plus 6. Sometimes it's a good idea to I was just searching for it on the page. This is the equation I'm subbing into. So sometimes it's worth putting a box around it because I was just searching for it. Y equals a negative 6 plus 6, or y equals a 0. And again, whoops, I didn't process this one. Putting all these on the graph should end up with a straight line. So that was that 1, 3 I forgot to do, and a 2, 0. You can see that those 3 points are in a straight line. And so here it comes. You know it's going to be bad. Oh gosh, well, that was really bad. There's my straight line. You can use your imagination on that one. Hopefully you can understand the math behind this, even if it's not a stellar video. So that gives us the equation of the line graphed. Another one for us to do here. Again, this one isn't solved for y, so that's what I need to do first. I would start by subtracting x on both sides. I'd get that 3y equaling negative x plus 9. I have to divide by 3 on both sides. So this is where I can see some fractions coming. The equation of the line all solved for y would be y equaling a negative 1/3 x, going from that binomial divided by a monomial there, that fraction work we've been practicing, plus 3. Remember on these, you need both things divided by 3. So maybe we need to show you the fraction work outside again, but this is the equation of the line that I'm going to be using to sub into. So because I have a coefficient on my x term that's a fraction, I need to be careful about what values of x I choose, unless I want to graph fractional coordinates. So in this one, I'm going to pick a 0. I'm going to pick a 3, and I'm going to pick a 6. I risk running off the chart or off the graph, but I'm going to go with it. So I'm going to evaluate my equation for x when x equals 0. So that would have me say that y equals a positive 3. And I'll try and be good about this and graph them as I go. That would be the ordered pair that I just found as a solution to this linear equation. The next one, I'd have y equaling a negative 1/3 times 3 plus 3. So some fraction math here. That would be y equaling negative 1 plus 3, or y equals a 2, filling in the blank. Go in the distance with that one so I don't have to come back and process it later. I could graph that on my graph paper. The last one, I have the y equals a negative 1/3. 6 is the value for x that I've chosen. And completing it, it's a +3. I've got some fraction math to do. I've got negative 6 divided by 3, or I can write it out as the fractions, however you like to think of it. I get y equaling negative 2 out of the fractions, +3, so y equals a 1. And hopefully, like I've said, these are just backup when you get to this third point, but it should make a straight line. So here goes, last one in the video. I'm going to try and connect the dots. It's better if I don't think about it. I get nervous if I try too hard. A straight line that is this equation graphed. So that's the first method of graphing. We're going to talk about the intercept method next, and then about the horizontal and vertical lines.